The light bulb is composed of a glass bulb, inert gas, tungsten filament, as you can see here, contact wire that goes from the tungsten filament to the foot, and a contact wire that goes from the other end of the tungsten filament to the base. We have the base, the electric contact. So for a light bulb to glow, a voltage must be applied across its terminals, which are the base and the electric contact. So we have to apply a voltage across them. For a light bulb to glow, a voltage must be applied across its terminals. When the lamp burns out, the tungsten filament burns out and it cuts off, it breaks the circuit, acting like an open switch. In series grouping, when a lamp burns out, it acts like an open switch. So what happens is that if this one burns out, then then that circuit will open and L2 won't glow anymore, will turn off. However, in a parallel grouping, if one of the lamps burn out, acting as an open switch, the other lamp remains functioning normally because the current still can pass through a closed circuit. Now for the lamp we have rated voltage and rated current. Now we need to study how or when would a lamp burn out. So we have the so-called rated voltage written on the lamp. Like here the rated voltage is 220 volts to 240 volts. So this is the voltage needed by the lamp to function normally. And the rated current is the current that flows through the lamp when it functions normally, which means that when the lamp receives the or is between or that its terminals are under the effect of a voltage equal to the rated voltage, then the current that flows through it is equal to the rated current written on it. We have three cases. If the lamp receives a voltage equal to the rated voltage, then it functions normally. If it receives a voltage less than the rated voltage, then it glows weakly. And if it receives a voltage greater than the rated voltage, then that goes brightly and may burn out. So this is the case in which the lamp may burn out.